So for creating, in Elab, so if you close it, this is the window that you get. So you basically start the Elab. I'm just going to go into my dev server just to, whatever protocols we're creating, it's just going to be a dummy one. So I'm just going to go into my development one. Okay, so this is the windows that come up when you log into your Elab. These are the two. So to create a new protocol, what you need to do is first define what protocol you need to create. Okay, and that gets done using protocol types. So if you go under the protocol tab and protocol types, you click on this. This is the window that comes up. So you put in a new protocol type. So you add this, and the bottom column is what you fill up. So do you have any protocol in mind that you want to create, Silvana or Rama? Can you think of one?
Can you do an ELISA one?
Okay, let's do an ELISA for the P24, okay?
Perfect, yeah.
So we'll do that. So for P24 ELISA, so I give it a name. So ELISA P24 assay, okay? So I give that a name. This is going to be obviously for HIV, so use the organism which is going to be suitable for, can choose all, if it's a standard assay, can be used across all different, Homo sapiens or HLA or organisms, you can choose all or whatever. So these are drop down, what we have some. If you can't pick up the ones that you already know, just choose all. That doesn't really matter. The number of tasks, so this is just one. It's in one assay, one-stop assay. Number of controls. Normally in ELISA, you want to have a positive control or something. So I would say one positive control. Number of primers, 0. So this doesn't contain any primers in there. And then what kind of a method it is, you can choose ELISA in here. And what kind of a default plate you would be doing it. So it's a 96 well plate that you want to set it up in. So where you're going to perform the assay. And so you
is it possible to eventually go to 384?
ELISAs in 384 won't work, Silvana. That's too small. And I don't think you've got flat plates for 384.
Okay, no problem.
Okay, so ELISAs will probably need to be done in, you can do half volume plates. ELISAs, you have half volume, so instead of doing a 200, I think you can do up to 100. So you've got those half volume, but it's still a 96 well plate.
Okay.
Okay, and then these columns here indicate whether a test is required. So when you perform an assay, obviously for ELISA, you want to go and have a look. You're going to do spectrophotometry there to see whether it's worked or failed. Okay, so I would say yes, a test is required. So test required, when we come to it, is when you say the task is processed, it will give it to be dark green, and then you assign them to be saying whether your sample is passed or failed. It won't let you go to your next task until you have assigned that the samples have worked or failed. So that's what this test required does.
Yep.
Use the same container. This thing you would choose if suppose you're doing a dilution of a sample and you've got only one row of sample and you want to do the dilution also in the same plate, then you can tick on this and it'll let you use the same container in which your previous samples were to let you do the dilution. But in normal things, you wouldn't use it. So when you're starting to write the methods, make it very simple, which is straightforward. Don't complicate the things. This transfer only helps you when you're transferring samples. So if you've got samples in a storage container and all you're doing is normally the racking steps, when you're writing a racking protocol, you want to tick on the transfer only. Okay, the transfer only will tell you whether your sample, all you're doing is there's no change to the protocol, there's no change to the sample type. All you're doing is transferring the sample from one container to another. So it retains the property of, it lets you add your input and output to be the same sample type. You don't have to change the sample type. And that's what it allows you to do with transfer only. This from container and to container again is used for sending the samples to storage or taking the samples from storage. The from container would be if you're doing a racking step, to container when you're sending your samples to storage. Okay, and these rest of these ones are, you can ignore them for now. These set fragments, set sequencing primer, all these are for cloning and Sanger sequence data. We don't really want to do that at the moment. It's not going to be useful to you at this stage. So, but all these things you'll see if you can, refer to some previous protocols where these things have been ticked, and that will give you an idea of what this gives, if it's going to be of any help. But this doesn't stop you from running the protocol in any way. So if you don't untick it and later go on down and tick it, it will help you or not, but doesn't stop you from creating the protocols in any way. So once you've chosen this, just save the protocol. So I go on top and save it. Once this protocol is saved, it gets assigned a number. And now I close this window. So that's my first step. I've gone into and created the protocol that I want to do. The next step is to go and type the protocol. What is it that is required? So you go to the protocol version editor. And now if we go through this window, the P24 assay, the protocol would have been created because we created it here. So there are a lot of protocols over here you can see. So there should be the one that we created today. So ELISA P24 assay. So you can see the rest which have been created have a plus sign in front. Anything new would be just a new, the name will be there because nothing is being added into it. So now if I go and say create the new one, so that it opens up, makes all these other windows active. So the first thing you say is this is a working protocol, and you can put in your comments here. So this assay is for, P24 GAG sample, whatever. I'm just randomly writing something. Okay, and then this comment will show up on your performer. If you want to write in what the steps are, some checklists, you can add them over here if you need to. Now the reagents that get added in. So first thing I added is the sample type. So for this, you're going to need P24. It would be on cells, or it would be cells, isn't it?
Yes.
So I would go and use a cell line and add that as an input. I could have a cell pellet, also could be an alternative, or just the cells.
It could be serum or plasma.
Okay. So if it was serum or plasma, then we just go and choose plasma and add that as input. So I'm going to remove these if it's not there. So if you accidentally added something, you can go and delete the type. Okay, so let's say it's plasma here or serum. So these are all the sample types that already have been added into the database. So if you're writing a protocol, sorry?
Do you have a supernatant?
We don't have a supernatant here. So if you don't have a sample type that you need, then you need to get that added in. So at this stage, if some sample type you don't have and it needs to be added in, just send that off to me or to Dan. So he'll register it into our database, and then you should be able to see it. So we need to publish that there, and you should see that. At this stage, we can't add any new sample type on our own. This needs to be done by Dan.
Yeah, no
into
problem.
the database. So we've got plasma and serum. So these are the two, any of them can be used. So either plasma or serum. If it's any other kind, it won't let you do it. So should we just try adding just the cells, Silvana?
Yeah.
Let's just do cells as what would be the supernatant. I don't think we've got cell supernatant here. Just let's put cells. Okay, so that's your input for your sample type. And now you need your output also at the same. What kind of an output you're going to get out from here? So in this case, it's really, there's no output that can be looked at. Let's see. What would be an output for a P? I'm just going to have a quick look over here. What you've got some ELISA assays here. So it's serum and serum at the end. So, and would you be diluting the serum?
Yes, potentially.
So we would put in diluted serum too as another sample type that can be used. Again, I'm going back because I've moved into a new protocol just to go and check. I hadn't saved the previous one, so I'm going back and adding these things again. So serum and diluted serum. So these are in alphabetical order. So that's your sample type. Now my output is also serum. So output can only be one. So you just everything as an output this Elab allows you to have only one output. So I'm just going to use output as serum. Okay, you can have multiple input types, but your output can only be one. You can't have multiple outputs. Okay, so that's my sample type that I've added in. Now I need to add the reagents that need to go into it. So let's just, for randomly at this stage, I'm going to just add some antibody.
Mm-hmm. Also, I need to ask you whether these robotic systems and the containers and the lines, etc., could tolerate sulfuric acid.
Sulfuric acid. Very diluted, probably yes, but not concentrated.
Okay. It won't be concentrated. It's part of the stop solution.
Stop solution for what?
For the ELISA.
But it should be very high, isn't it?
No, it's not. It's not high.
Yeah, and you're using tips, so I would just use them once and throw them off. So it should be okay. I don't think it should be, as long as making sure that it doesn't get sucked into the system, it should be okay. It should be fine. Okay, so at this stage, I'm just putting in this, and PBS is probably you'll be using. So here you're just putting in what you need as PBS Gene 20. I think I remember seeing that was used for washing. And can you think of anything else at this stage? I don't have the protocol. What you would have is really, the protocol in front of you to say, okay, what my sample type is going to be, what are the reagents that go into that assay, and what my output is going to be. So create that with the volumes that you're going to be putting in. Now for each one, you need to define what volume is going to go in. So for plasma, let's say I'm going to put in 100 microliter of plasma. So same thing would be for serum. So any volume, so that's my input volume that I'm going to add in. So more volumes have to be defined in the protocol. Okay, so in reagents, antibody, am I adding 10 microliters? I'm just randomly putting this, but this is how you would be creating this. And if the concentration, you know the concentration of the antibody, you can put that in here. Suppose this was critical that you put in at 50 micrograms per mil or whatever. You can put that information there. Okay, but it's not compulsory to put the concentration. But if you know what you need to use, so for example, primers for PCRs, you say you have to use them at 25 picomole per microliter, then add it here so that people know if they want to go and look at it. PBS, again, I'm going to add 100 microliters of PBS to my sample. And then this is going to be for washing. You can just say wash it with, I think it says 300 microliters of wash, or 200, I think, whatever it was. But that's going to be done with the washer. But doesn't matter, you can just need to keep all the reagents that you've added in. And at the end, my output is going to be 200 microliters. After adding my plasma and my antibody and everything, it adds up to 200. Okay, so I've gone in and defined what I need, what my reagents are, what my output is, and then you save it. So in this case, we haven't added any primers because my protocol said there's no primers. So if it was a PCR setup, I would go and choose the primers for a particular PCR. So all these are different primers or peptides that are there that have been registered in the database. So you can choose them as you want, right? So if it was a PCR, normally what we do, I'll just give you an example and I'll take it out later on. So if these are forward or the reverse primers, so you can add them as different groups. Group 1 as a forward primer. I'll just take the example of HIV, make it easier, or Hep C.
Yeah, I remember seeing that the forward and reverse are different groups.
Sorry?
No, I remember seeing that the forward and reverse primers are in different groups.
That's right. So, you can, I'll just show you how to add them in. So if I say this becomes my forward primer, and this becomes my reverse primer. So you add all the primers once, and then you choose these and have a group, new group, and put in as where is it? I have to create a new group here. So go into the primers, create a new group, and then another new group. So it creates group 1 and group 2. And now you choose that and say add that to group 1. And this one add to group 2. Okay, so now you'll see these group 1 and group 2. So you can separate them out. So if you've got multiple different primers that you could use in the PCR and you would just want to choose only one pair from each, that's how you would do it. Okay, but in this case, I'm just going to remove it because we don't need any primers. So that was just an example. Okay, so you've got your protocol and then you save it. So once you've saved it, it says if there are any previous versions, they become inactive and only one version is going to be active at one point, and we just say yes. Okay, so now if I go on and have a look at that protocol, ELISA P24, the version 1 is being created. Now it won't let you edit that version. So once a version is being created, it won't let you edit it. See, it won't let you, this windows will not come out. The only time this will let you do it is when you create a new version. So once a protocol is being created, that's the version that's been assigned to it. So any change to it becomes a new version. You cannot go and edit that version anymore. The only thing you can view it, you can edit the CSV layout. So if there was a CSV layout that I created, we'll go to that, how to create a CSV layout. So I choose and CSV layout, and will create a CSV for P24, but at this stage, if I have a CSV layout, I would choose that on this and say, okay. If I chose that, then that's how the CSV layout template will be created whenever that protocol is generated for it. At this stage, I'm not adding a CSV layout because it's not the right one there. Okay, so that's done. Is that clear, Rama?
Yeah, it is. But what if can we add the reagents, if that are not in the database?
No, so you can't add any reagent that is not in the database. So anything that you need to add first needs to be added into the database. And I'll show you the reagents and primers can be added by whoever is creating the protocol. So I'll just go out of this now and I'll show you how to do that. But the new sample types can't be added in. Okay, but if you go under materials, there's a reagent editor.
Okay.
Okay, so if you had, suppose you needed a reagent which is supernatant, but that's not, supernatant is not really a reagent, that's a sample type. So I wouldn't add that in here, but there was a Liza wash or whatever, something that's not there. Sorry?
For this ELISA protocol, there is a staff solution, which is sulfuric acid, I think, 2 more.
Yeah, and so if it's not there, then you'll have to add that.
Okay.
Okay, so if it's sulfuric acid, so I would go and say H2SO4.
Yeah.
Okay, and so it's 2 molar, so if I want to just add 2 molar sulfuric acid, okay, and storage type, it's probably in a bottle, so create a, this one, and it's stored on the bench,
Right.
okay, and at this stage, you can just use SIBS as the group and insert it. So now this would have, reagent has been added, so that would have been added. Okay, so you can go in and keep adding any reagents which are not there. So now when you go and create a protocol, so make sure before you go and create a protocol that all the reagents are there in the database.
Right. Also, the same thing with the primers, if you want to add new primers.
Yeah, so for new primers, so if you go into, there's a primer editor.
Okay.
Okay, so when the primer editor, this should come up. Why it's taking this long to come up? It's possible because I'm on the dev server this is happening. It shouldn't happen. I'm going to just close this, go back and see what's happening. Yeah, so primers, again, you need to, I'm just going to go into, let me see if it works here. See, this is the primer window that will come up.
Okay.
Okay, and here you can say a new primer. And then this window becomes active. You can give the name of the primer. So suppose it's, whatever.
Yeah.
Eliza F2, whatever you call your primer, whether it's a forward or a reverse, your sequence of the primer, whether you've tagged it, so if it's called the M13 tag or not. what organism it belongs to. And the only one that is compulsory that you need to add in is, when you put in, some of the fields are not compulsory. You need to have the location. So container name, normally I would create a container where I'm going to put in. So if you just type in primer box, you should end up having these primer box. So you want to go into the container first and have a look at which wells are empty. Okay, so which wells are empty, then choose that container and put the information in. So choose this primer box, row number. So these numbers are, rows are obviously going from left to right, and column is going from top to bottom. Okay, so that information, so these are just numbers. So row 1 and column 1 will be A1 position basically. Okay. Yeah, so you can put that information in. So row 2, column 2 will be B2. Okay, so I don't know whether you all use alphanumeric numbering system or this, but this one you just have to put numbers. This doesn't accept alphanumeric numbers. Okay, and if you've got a plate barcode, you can use that to information here. And once you fill all the information, whatever you have, if everything has been added, just say insert, and it will insert the primer into the database. Okay, so I won't go into that one here because I'm working on the dev the working one here, so I won't add that in, but that's how you would go and add the information. So I'm just going to go back to my dev server. Okay, so we've added in the protocol type, we've created a protocol version, we've added the reagent. So first step you want to do is protocol type, then add in any reagents using the reagent editor and the primer editor. Then go on and write the protocol using the protocol version editor. And the next step you want to do is to protocol action editor. Okay, so what the protocol action editor does is it links multiple protocols together. So, if I've done DNA extraction, after DNA extraction, I want to do PCR, for example. So I want to say after my first round, so if, for example, I'll just take you through DNA extraction step here. So if I've done DNA extraction, the next step, if my extraction was successful, I would want to do my DNA dilution, or I want to send my DNA to storage, or I want to do quantitative assay. Okay? So I'm giving it all these, and if it's failed, go back and repeat my extraction again. So it's giving you the option, once you've completed a step, what do you want to do with those samples after that? Does it make sense?
Yes. Yes.
Okay, so I'm allowing, and this is what allows me to show. So when I don't know if you remember, if you've seen the task window, once the samples are processed and you say send to task, in the send to task, you will have all those different options that now these samples, you can take them through all these different protocols. And this window allows you to add in what all things you're allowed to do with that sample. So anything then after being successful, I can go in and say, okay, after it's successful, I also want to set up a PCR task here, for example. Okay, and add it in here. So my default, you have to choose one as a default, that it will automatically let you do that, but you have those other options there. And if any of your samples that's failed the extraction, it won't let you do any of these. It will ask you to go back and do the extraction again. Okay, once you've added these, then you can save the edit. So let's do it for ELISA, for example, what we created here. So for an ELISA P24 assay, I'm going to say, okay, if it's successful, then do nothing. In this case, what we are saying is after ELISA, I really don't have anything much to do, right? I just have got a readout and there's nothing. So I'm not going to do anything after. I'm going to delete that step. So after, suppose it's failed, I want to go back and do the ELISA assay. If I want to go and repeat, either I might want to grow the cells again or do whatever, but I might want to go and repeat the failed assay. But as a successful, do nothing. Okay? Or if I say, oh, I want to go and do a dilution of my sample after I've done my serum ELISA, I might want to go and do a dilution of my serum. So then I can go in and say, allow me to do a serum dilution. Okay, so I can go in and choose that as a protocol and give that as a default. So once I've done that, this is just random thinking, and then save the edit. So once I've done that, it'll allow me to take it to the next step. And I can close it. So effectively, my protocol is ready, except for now the CSV file. Now I want to create a CSV file. So the next step is creating a CSV layout for how I want to do it and an automation. So for automation, you need the CSV file, right? And this is how I'll go and do the CSV layout. So just as an example, so let me see, I've got an ELISA as a reference. So what all the information that I need on my CSV file. Okay, so I've got an information column. So information columns basically just extract the information, pull out the information from the database. Here I'm saying in this column, so the first column on my CSV file will be a record number, 1, 2, 3, 4. So every CSV file we have this as the first column, the record number and what the sample number is. Then the next one is information column. I want to know what my task ID was, what was my task number. So that is a good idea to have that as a template. My second column is going to be the base ID. So that's my sample identifier. So I want to get that information. What sample went into which well, I need to have that information recorded. And my third information column is my sample ID. So, these are normally, we use these as default on all our CSV files. And then we leave a blank column. So these are all just chosen. So when I'm creating a new one, I just go into an old one, look at the template, write down what these columns are, and then I go and create a new one. So I'll just tell you that. So these are all drop down. So I choose everything from the drop down. There's nothing typed here. Okay? So now let's create a new one for our P24. So I'm creating a new CSV layout for P24 ELISA. Okay. Now I go and choose the new one. So P24 ELISA. So you see it's empty. Okay. Now where do you want to do it on? Whether you want to do it on pre-PCR effects or your post. Doesn't matter in your case where you want to choose it, but we just use it as pre or post, wherever you want to set this up as. So I'm guessing this will be your pre in the cellular robots. Now the first thing is the record column. So I go and choose that. My second is my information columns. So as you saw there were 3 information columns. Okay, so I'm choosing that. Then I'm choosing a blank column. That's for barcode. Normally we keep that if in future we're going to use a barcode to scan a plate or whatever the samples. We'll use that. And then, if you're adding some reagents, I would use a reagent column. If you are adding a master mix, then I would use a master mix column. And Then the next two are the source columns and the destination column. What these source and destination columns give you, I'm not sure if you've seen any CSV files that we have. Source columns will give you the information of from where are you picking up on the deck, from which position you're going to pick the sample up from. So, if it's a 96 well plate, a 96, where the DNA is stored, that becomes your source plate. Okay, so it wants to know what's the name of the plate that you're going to pick up your samples from. It also tells you which well in the source that you're going to pick up the sample from. And it also gives you the volume of the sample that you're going to pick up. So it generates three different columns. For source column, when you use a source column, it will automatically generate three different columns on the CSV file to give you this information, the position, the well, and the volume of the sample. Okay? And then the destination columns will tell you where is my sample going into, and so again, which well it is going into and which position it is going to. So the destination columns create two different columns on the CSV file. Okay, so now I'm going to go and fill up the right-hand column. So I've filled up all this information. So here, whatever you want to name the heading on the CSV file, I'm going to put that in here. So now information column, see the moment I click on it, this information comes up here. So this tells me what do I want the information, what information do you want to pick up from the database for that information. So here it's the destination task number. Okay, that's my task ID on the Elab. So I can go in and choose that as my task ID. The second one is here. Now I'm going to choose the base ID. Okay, and that information is the base ID, and that is what I want. So it will go and pick up the sample information and put that in here. Then the third is the sample ID. So I'll go in here, select the sample ID information from the database. So it's going to pick up that and put that information here. Here, nothing, it's a blank column. So I'm just going to say barcode here. And now the primer reagent column. So the primer reagent column is basically if you had your antibodies in a plate or a reservoir, that's what you want to pick up, and you want to add certain volume to it. So I would go in and say, this is a plate called antibody, where it's going to pick it up from. It's just one tube of that. Just leave it. It's a 96 well. Per one tube is enough for all 96 well. And whatever reagent I want to add in, which was written in my protocol, I would choose from here. So here we added some antibodies in here. So I'm going to go and choose that HRP conjugated antibody. So that is the reagent. It's going to look into the protocol and say, okay, this was, remember we added this as 10 microliters. So it gets that information from the protocol to say, okay, we've added antibody, which is HRP, and added 10 microliters of it. That's the volume I'm going to add into all the wells. Okay, and I'm going to take it from the plate of antibody, plate which is named antibody. And that's it. So I've defined that here. So I can go in and name this plate as antibody. And that's the information it will take it from. Then the source columns, again here, I'm going to call this as source well. So for source well, I just use the source well location as my thing. What my source is going to be called could be serum. I'm just going to name it as serum. And because that's where my serum samples are going to be stored. and my destination is ELISA, for example. Okay, that's where my samples are going into. So my plate name will be ELISA, and here I choose destination. Well, and name this as ELISA. Oh, what happened? It's hitting an error. And what you can go and do if this becomes confusing, just go to some reference CSV files and have a look at each one and see what it's given, and then it will go and do it.
Yeah.
Okay, so once that's done, you can save it, and this is created it. Okay, so now I've created a CSV file. Okay, it's got all the information that I need for my ELISA. And now I can close it. And now remember, in the protocol, when we created the protocol for ELISA, we need to link now the CSV file to this assay. So I go back to the P24 assay that I created. Where is my P24 assay? So I go in, choose the version, and go and check edit. And now the CSV layout, I can go and choose the P24 CSV file layout, ELISA as my assay that it's going to use. Okay, and if I'm happy with that, just save it, and it's all done. So this way I've created the whole protocol, starting from protocol type, then adding materials, whatever I need to add, and then I create the protocol version editor, create the protocol, and I then link all the protocols, what is going to, after I completed this protocol, what I'm going to do with it. And in protocol action editor, one thing you need to remember is that when I do this, yes, I went and chose what my samples are going to do after I've completed this assay. But what you also have to do is, where is this samples coming from? Which assay is going to let you use this assay? So for example, if I've done serum racking, so I could have plasma racking or serum racking because I need that. That should allow me to go and add this sample. So if I went into serum racking, see here, it's allowing me to either directly add the samples, the successful, and it should let me add the P24 assay. So once I've done serum racking, it will allow me to do the P24 assay from there. If I don't add this in, it won't let me go and do this assay. It will only allow me to do these assays that I've had previously. Once you've added that in, save the edit. I would also like to do it after I've diluted my serum. I would like to go and do this assay. So I go into my serum dilution and again add that information in to say it's successful, and let me do my P24 assay from there. Okay? Is it making sense or no? I'm just...
It's making perfect sense, Elab.
Yeah, that's great. Yeah, I can add.
Okay, so now I'm just going to go in and choose this P24 if I can find it, even if it's already there. Okay, and save. Okay, so I've done that. Oh. And that's it. So I've created, now my protocols, I should be able to go and generate a protocol. Now how do now this is basically what you would do to create a new protocol. So if you've got any questions, here we'll stop, and then I'll go through how we go and generate a task now for this.
Okay.
No, I think that's, I don't have any questions at the moment, but what I might do, Abba, is watch the video again. And,
Yes, definitely. So once I've got all these still recording, I'll send it off to you all so you all can go through and see if it makes sense.
Perfect.
Rama, what about you?
Yeah, I think that's, yeah, we can do it, except, we're going to watch it a few more times.
Exactly, exactly. So that's how you create it. So now I'll just quickly go through how I would go and create a task for this one. So now I want to go in and look at containers which have the serum, right? Because I need serum to start with. So I'll go into the containers, and I may have it in a project. I know where my serum is, or I just put in as serum, search for a box which is containing serum, and obviously use the ones that you really want to use, not just random ones, but I'm just going to do it, a test one from here. Okay, so the serum samples come up.
Well, this one's almost as slow as remote desktop.
I know something is not right because I'm doing a dev one. If something is happening in the dev, it could be taking long. It shouldn't take it. So here we've got only one sample, so that's perfect. Okay, so I've got this sample. I can send to task from here. So I choose that sample and I send to task. And then this window comes up. Okay, so I'm going to do serum racking. Anything from storage, it's always ideal to take it through racking step. Racking will allow you to go back and put that sample back into that location, and especially if your boxes are 9 by 9, which can't be put onto the robot. You need a racking step. So I would always take anything from storage onto a racking before I do anything. So it's a 6 by 4 rack, which is suitable for a robotic setup. Fill the columns how you want to lay out on the plate or the rack. You can fill by rows or columns. Default is set up by column and creates a new task. Silvana, I'm expecting you already told Rama how to add to existing tasks.
No, I didn't. I just went to create a new task.
Okay, so if you create a new task, suppose you already have a racking step you've done previously and you haven't processed it, you can go in and add something to a existing task. You have to type in the task number here, and then you have the option again to fill it from wherever it's empty or fill it from the next column or the row. So whatever you want to do, you can do it from here. Okay, but here, because we don't have a previous racking task, I'm going to create a new task, and I'm going to close it and make the task. So this is the 33043 that is left. Okay, so let's just do, I'm going to go into another container. Okay, and maybe add another sample from some other sample into this existing task, so you'll get to know how to use that one. It's taking ages to open containers here. Okay, so here the selector window also gives me an option how to choose samples. So if something is by base ID, I can sort samples. I know what my base ID is, or I want to choose by whatever I've got the volumes, only ones which I haven't used before. So I can go and choose. So the moment I choose a sample, clicking here, it tells me how many samples I've selected. So if I randomly just go and pick up a few, so it tells me I've selected 4 samples. Okay, and if I press OK, it selects all the 4 that I want to use, and now I can send it to task from here. Again, the same window comes up. but this time I'm going to add to an existing task. So I'm going to put in the existing task 33040,
The task number.
okay, and fill the columns from the left. So now previously we added only one sample. The first column is empty. So I might want to add it from the first column, but maybe no, I don't want to add it there because this is a separate set. I want to treat it starting from a different column. I just go in and say, no, add these samples starting from column 2. Okay? And now if I close it and make the task, it should go and add it over there. You can assign users. All these things are, you don't have to do it, but if you want to, you can add them or assign it to somebody else or whatever.
Okay.
And then you make the task. So now you don't need the container. I can close the container window, can close this task, and now if I go and open the task, see the task for the serum racking is being created, and let's see what this task looks like.
While I've been watching this, Abba, the Australian dollar's getting stronger against the US.
Oh wow, why is that?
Don't know.
So this is the time for you to do shopping, Silvana. Okay, so you see how the samples, so first sample went into this and the remaining, because I said I want to start from column 2, it's gone and done the ranking there. So basically now I go and every task, whenever it's generated, you have to save it for it to show the performer. So I'm going to save the task. Now it's the same cycle that you do every time. So if you created the protocols correctly, it should let you go through the whole thing without any hassle. Okay. So it's generating the performer and saving the task. So now if I go and look at the performer, so it will generate the performer only after you've saved it. So if you try and view the performer before that, it won't show you anything. So it saves it into a set directory. So I'm guessing when you all have the Elab, it will save it to a directory that it's been set for. So this is how the performer will look like. Okay, so what we've done, and this I'm sure you've had a look at, so I'm not going to go much into the detail. Now once you've done the racking, now you process the task. So it says I cannot just say yes. This is because I'm working on the dev server, it can't find the performer in the directory, so it just tells me that. So should be okay. So once I've saved the task, these should all go light green. And once it's light green, that means it'll allow me to go to the next task. It's taking ages, but it's taking longer than normal because I'm working on the dev server. But it's much quicker if you do it on your...
Only Elab.
Okay. So it's got the thing, now I can send it. So sometimes, even though it's green, it's not making the tab active for send to task. If this happens, just close the window and go back to the task and it should let you do it. Okay, now it will be, just go into the processed window. So the status, because I've processed the task, you will not obviously see it under the waiting. But if you should see it under the process task.
Okay.
And now it's going to take this. Okay, see now this window has become active, the tab is active, send to task.
Okay.
Now see the ELISA, because remember in the action editor we asked it that after racking I want to go and do the P24 assay, it's come up over here. So I can go and choose this and double click on the assay that you want to use. Make sure the container is the type of the container you want to set the assay up in a 96 well plate. Again, choose whether columns or whatever you want to do it, whether you want to send all the samples, and click and select the new task and make the task. Okay, so it's now pretty much going back and doing the same thing over and over again. So if you created the action editor, it should let you go and do everything the way we've done it. So let's see if the CSV file works. Here, so it's going to load the task. So we'll quickly just go through this, and I think we should finish after this. I realize it's too late for you all now.
Yes, it's past my bedtime.
I know.
It's not.
Welcome to the world, Silvana.
Yes, I've been there.
Ava is working 24 hours a day.
I know. Okay, so see the protocol that we wrote is now come up, right? So you've got your samples that we don't need this window. Now to add the reagents in here. Okay, so you've got this. If you want to add the reagents, just double click on these reagents and I've added all the stuff that's happening here. Okay. Now there's something not right. So you've got my plasma and my output is serum. Got everything here, and now save it. I've added my reagents. I've added this. Let's see if it generates the task.
Okay.
Should save and create a CSV file. This is really slow. So it's generating a CSV file, which is a good sign. Silvana, did you get that mail from Forensic? Did you reply to Gon?
No, I haven't read. I'll reply to him tomorrow.
Okay. Okay, so looks like it hasn't generated the CSV file for whatever reason. It doesn't like the format of the CSV file, so it hasn't generated it. But it's also possible that because they're on the dev, it's not generated, so we'll have to have a look. But if it had generated the CSV file, you would have the directory where it saved the CSV file would come up here. But obviously for some reason it hasn't generated the CSV file here. So again, you've got your performer and not sure why it's not generated the CSV file. It does not exist here, otherwise it will show up here. Something is not right. Okay, so it would have, so let me go and show you what the CSV file would look like. Yeah, this is, it takes ages like this, it spoils the whole show. Shouldn't take this long. Obviously this again, I'm choosing the wrong one. I hope you all are not sleeping there.
I haven't started snoring yet, Ava.
Look, I think these are something you all can have a look at. I don't really need to show you. You should be able to see the CSV files there, but I'll try and fix it up so when you all come in tomorrow, you should have these things working.
Yeah.
But I think you've
That's
got
fine, I
a big
think so.
idea of what this is. For some reason, it's gone very slow, and I don't know how I can fix it now. I wouldn't bore you with that.
I've taken Rama through the CSV file.
Yeah, so it should,
Yeah.
so that's what the CSV file, if it's there, it tells you where the directory is. And maybe because it's sharing it on GoToMeeting, screen is being shared, that's why. I don't know why it's taking really long to do it. So if I now view the CSV file, I should see it. Because it's going back and forth, maybe that's why, but it's taking ages. Normally it should pop up quite immediately. So you should see this directory, then you'll know my CSV file is being generated, and it will have the relevant columns. So this is the performer. And okay, so now here this is the CSV file. So Rama, what I was telling you, the source columns will generate these three columns here. The DNA P means the position. So my plate is going to be called DNA sample in this case. The well number it's going to take is these ones, and the volume it's going to pick up is this. And my destination information is telling me that the sample from A1 is going into a plate called PCR and into the well A1. So this is how it's going to be taken. And in the reagents, the master mix is where again the master mix column will show you the position, the well, and the volume. So whenever you choose, it creates three different columns. And the robot will then use these column informations to use for preparing. Okay, so that's how the CSV file will normally look. As I said, the first column, the sample, then the task ID. We had the base ID as the next one, the sample ID, and so on and so forth. So this is how most of the CSV files would look. And the important thing is once you've created the CSV file, then don't change it once it's been implemented on the method, because the robot doesn't like things being moved from one column to another. So if you had to change something, then you have to change it on the robot from where it's going to get that information from. Okay, so that's how you basically go through and repeat the same thing again. Create the task, process the task, and then send it to the next task, and so on and so forth. So that's pretty much what the end of Elab is. What I would recommend is